Welcome, dear students. Today's topic is Lagrange's mean value theorem. The theorem is also known as first mean value theorem. Here the statement of the theorem is, let f of x be a function which is defined on closed interval AB, such that a function f of x is continuous in closed interval AB. A function is continuous, the function must have a continuous graph, so that the function is said to be a continuous in that interval. Second condition is that a function f of x is differentiable in open interval AB. Then, according to the theorem, there exists at least one point C which belongs to the open interval AB, such that f dash of C is equal to f of B minus f of A divided by B minus A. Next, see the geometrical interpretation of the Lagrange's mean value theorem. Suppose we have a function which is to be defined in the closed interval AB. First condition, the function is continuous, which means that the curve of function y is equal to f of x is continuous. And second condition for the Lagrange's mean value theorem is that the function is differentiable in the open interval AB, and the geometrical meaning of the differentiability is that the tangent exists at each point on the curve excepting at the endpoints. That is, it does not get a tangent at the endpoints. So if these two conditions graph gets satisfies, then according to the theorem, then there exists at least one point C on the curve except the endpoints, such that the tangent at C is parallel to the line connecting the endpoints, and such a particular line is known as a secant line. And the graph of the function as shown in the figure. See here, here is the curve, is a curve of the function f of x. It is a curve of the function f of x. The graph is continuous and differentiable, so that according to the theorem, we get a point C at which we draw here the tangent. The tangent at point C and the line which joins the endpoints, both are the parallel. And we know that if two lines are parallel, then their slope are also equal. So that here f dash of C is equal to f of B minus f of A divided by B minus. Now we will see some examples on the Lagrange's mean value theorem. Here, the first example is verify Lagrange's mean value theorem for f of x is equal to x into x minus 2. And the function is to be defined in the closed interval 1, 3. Now, to verify the Lagrange's mean value theorem for the function, first we write, consider f of x is equal to x into x minus 2, which is defined on the interval 1 comma, right? To verify the theorem, Lagrange's mean value theorem, in short, we will write LMVT. First check necessary condition. First check the necessary condition. So the first necessary condition for the Lagrange's mean value theorem is to be applicable for the function. So the first condition is continuity. Continuity. A function must be a continuous in the interval, close interval 1 comma 3. Here, the given function is polynomial function of degree. We know that polynomial function is always continuous. It's always continuous. So that f of x is equal to x into x minus 2, which is equal to x square minus 2x, is continuous in close interval 1 comma 3. Now the second necessary condition is differentiability. Now, to check the differentiability of the function, here first we find the derivative of the function. So the derivative of the function is f dash of x is equal to 2x minus 2. And observe that derivative exists every point the interval one comma 3. So implies that f of x is differentiable in open interval 1 comma 3. So the function satisfies all the conditions of Lagrange's mean value theorem. Therefore, by theorem, there exists at least one point C which belongs to the open interval 1 comma 3 such that f dash of C is equal to f of B minus f of A divided by B minus A. here the points A and B are f dash of C is equal to f of 3 minus f of 1 divided by 3 minus 1. So f dash of C is nothing but the value of the f dash of x at x is equal to C. So here we get 2C minus 2 is equal to the value of the function at x is equal to 3 is, so the f of x, which is x into x minus 2, and if we put here x is equal to 3, so we get 3 minus, similarly we find the value of f of 1 by putting here x is equal to 1 minus 2 is minus 1, so the minus 1 into 1, here we get minus 1, 3 minus 1 is 2. So the 3 minus 1, that is 3 plus 1, which is 4 by 2. So here we get 2C minus 2 is equal to 2. That is 2C is equal to 2. Here minus 2, if we shift minus 2 towards the RHS side, so the 2 plus 2 is 4. C is equal to 2. And in here C, which is equal to 2, which belongs to the open interval 1 comma 3, implies that we get point C which belongs to the 1 comma 3, such that dash of C is equal to f of 3 minus f of 1 divided by 3 minus 1. So therefore LMVT, Lagrange's mean value theorem, is verified. So this way we check whether the Lagrange's mean value theorem is applicable for the function. So here the function is given. First we check the continuity of the function and then differentiability of the function. And if these two conditions get satisfied, then we definitely get a point C which belongs to the open interval 1 comma 3 and satisfies this condition. So see the next example. Verify the Lagrange's mean value theorem for f of x is equal to log x on the closed interval 2 comma 3. So similarly the previous example, which is also the verification for the Lagrange's mean value theorem. So this example we solve, consider f of x is equal to log x and the function which is defined in the interval 2 comma 3. So the first condition here we check continuity. Here given function is logarithmic function. We know that logarithmic function is always continuous in its domain. So the function is defined in the interval 2 comma 3. Whatever the domain we have to given, in that domain the logarithmic function is to be continuous. Here the domain, that is the interval for the function, is 2 comma 3. So the log x is the continuous in this interval 2 comma 3. So implies that by using this note, we directly mention here f of x is equal to log x is continuous in closed interval 2 comma. Now we will check the differentiability. So first, to check the differentiality, we find the derivative of the function, which is 1 upon x, right? And observe that f dash of x is exist except x is equal to 0. And since x is equal to 0 does not belongs to the open interval 2 comma 3, implies that function f of x is equal to log x is differentiable in open interval 2 comma 3. So the function satisfies all the condition of LMVT. Therefore, by theorem, there exists at least one point C which belongs to the open interval 2 comma 3 such that f dash of C is equal to f of 3 minus f of 2 divided by 3 minus 2. So here, so the f dash of C, which is 1 upon C, is equal to log 3 minus log 2 divided by 3 minus 2 is, right? That is 1 upon C is equal to log of 3 by 2. So C is equal to 1 upon log 3 by 2. And if we find the value which belongs to the one interval 2 comma 3, implies that Lagrange's mean value theorem get verified.